Urban areas are not pristine natural environments to begin with. There's some amount of engineering going on anyway. Just dropping a practice in the middle of a watershed doesn't really allow you to think about how that thing connects to everything else around it. Bioretention, I always call it in my classes, the Swiss Army knife of stormwater management. Man, you just opened up a can of worms. There's challenges in the US with how we can manage and what we actually are allowed to regulate. This has become really interesting to me, this idea of where did this originate?
That is Jon Hathaway, Associate Professor in Sustainable Urban Water Management, Green Infrastructure and Urban Pollutants at the University of Tennessee Knoxville, USA. Jon completed his Bachelor in Environmental Engineering in 2002, as well as his Master's and PhD in Biological and Agricultural Engineering in 2005 and 2010 at North Carolina State University. He has a passion for natural systems, from wetlands to bioretention and other green infrastructure, and has been refining their design and implementation for stormwater management and combating climate change. My name is Peter Marcus Bach, and this is the Grand Challenges Podcast, a show about inspiring individuals who are stepping up to tackle the global challenges that our world is facing in their own unique ways. We reflect on the many out-of-the-box ways our guests have navigated the complexity and intricacies of the environment at the cutting edges of science, engineering, technology, and design. On today's show, Jon and I discuss and compare notes on the practice of green infrastructure in the United States of America and across the world. We not only cover technological aspects, including the so-called Swiss Army knife for green infrastructure, but also current challenges in regulations across the US. In stepping up to the challenges of climate change, we also discuss how to better harness green infrastructure's interconnectivity in watersheds through smarter design and control. Detailed information is provided in the show notes over at petermbach.com/podcast. Thank you for joining us today, and please enjoy the show. Welcome to the show, Jon.
Hey, thanks, Peter. I'm excited to be here and to talk with you today.
No, likewise, and I'm glad we could schedule this. And yeah, you are the first guest from the US to be on this podcast. So how do you feel?
That's a lot of pressure.
Yeah. Now, I've been to the US a few times. I'll have to definitely go back there and do it a lot more often, because you guys do a lot of interesting work around, especially my fields in the blue-green infrastructure space, as well as just generally urban stormwater management and combating climate change.
Yeah, it's a big country, so lots of different challenges depending on the region you're in. And then I think it's funny because I talk to people who come visit and they're going and visiting places that I've never actually been to in the US also. So sometimes, it makes me laugh.
Well, I haven't been to Knoxville, Tennessee, and I haven't been to North Carolina either, which is where you've spent also quite a bit of your time. I've been to San Francisco and Chicago and New York, so sort of the more touristy places. But we'll have to start seeing more of the country.
I know. I'm like, Grand Canyon. I've never been to the Grand Canyon. It seems like
really?
I should have done that by now. Yeah.
Yeah, that's on my to-do list as well at some point.
Yeah.
But you moved around a lot as well growing up.
I did, yeah. So kind of all on the eastern seaboard. But yeah, I moved around quite a bit. My dad was actually a pastor, so he was like a minister. And so, yeah, we ended up moving around quite a bit.
And so with that came also one of your passions, which you could practice quite extensively, which is mountain biking.
Yeah, so that's been kind of fun. I used to bike a little bit more when I was younger in like college, and I didn't bike very much for a long time. And then moving to Knoxville has kind of been a revelation. We've got a huge trail system kind of here in town, and then we're really close to the mountains. And so I would maybe biased would say, some of the better biking in the country in Pisgah National Forest over there in North Carolina.
I'll have to check it out. I used to bike a lot in Melbourne. They had the rail trails, so the old railway lines that were no longer functioning, but had some historical significance, and you can take your bike out and just ride around, and 70 kilometers in a day kind of works.
Yeah, that's amazing. I have been on some greenways in Melbourne before, and there's some commuters that go pretty fast on that thing. we were looking at a monitoring station and thought I was going to get run over.
Actually, I had a friend once. He would take his bike to work. He used to work in a restaurant. And I remember on our local street, they set up one of these speed monitors. And he was so proud of his bike because he had one of these road bikes. And I remember one night he came home and he felt accomplished because he managed to exceed the local street's speed limits on his bike. And I'm just like, why? Why would you?
Oh, man.
Yeah. No, but since I moved to Switzerland, I did buy a bike, a nice touring bike, but I don't know. I haven't been able to just go on a proper tour. Maybe I'm just a bit intimidated by all the hills and mountains in Switzerland. But
yeah, there's some really good really good bikers in Switzerland for sure.
Oh, yeah. I mean, they travel from Zurich over to, I guess, where I live around the area, just on the other side of the hill. And they just cycle over the hill every morning. And I'm thinking, how can you get up in the cold, especially in autumn, winter, and get on the bike and travel for that decent 45 minutes or however long they take? And maybe I'm just too weak on that. I'll have to, sort of go to the gym. And, now that we're in the new year, maybe I should do a bit more some exercise to get my stamina going.
The old New Year's resolution.
Yeah. But nevertheless, you're in Knoxville, Tennessee. You have been there for quite some time, but you actually were in North Carolina before that, where you began your studies, and you went all the way through from your undergraduate through to the PhD. And you work in a topic that, like I said, is very familiar to mine and very close to my heart, and which is in the area of blue-green infrastructures.
Yeah, for sure. So yeah, I went to school, and kind of the same story a lot of people have with engineering. I probably didn't really know what engineering was. I was just, it's the old, I'm in school and they're like, oh, you're good at math, you should do engineering. I'm like, okay, that sounds all right.
Oh, yeah, I know that all too well.
So I went to school. I was like, I'm going to build bridges. That's what I'm going to do.
I actually thought the same thing when I chose engineering. I was fascinated by structures and architecture. I always tell other guests as well, if I could draw better, I'd probably be an architect by now. But I was also good at math.
Yeah, so I started off doing that, and I did an internship, and I was just in a normal office doing kind of some basic engineering tasks, and I was like, I have got to have a job where I can get outside. And so that's when I switched into environmental engineering at that point. And our environmental program was, I don't know, we took a lot of classes in like waste management and wastewater treatment. And I think it was a great background, lots of the basics, but I was super like, I want to work with natural systems. This is kind of, I'd like to do all that kind of stuff, treatment, but do it with a more natural system context. And so, yeah, when I did my master's, I ended up moving into a different program that was more focused on natural systems. And then actually between my master's and my PhD, I worked at the university for about 3 years. I was in a position where we were doing outreach, we were doing trainings for professionals, we were doing applied research. And looking back, I'm like, that was a really fun time.
They always say the university period is sort of the highlight of your early years, when you really start to explore and see the world and, I guess, find what you're passionate about. I guess spending a lot of the rest of the years of your life on and most of your career.
Yeah, for sure. And that's, everybody probably tells their students that, but it's like, it's so much harder to learn new things after you're on faculty. It's so much easier when you just have more time available. So you kind of shift, and now it's like I learned a lot from my students and the topics that they're doing. And I always tell them, like, well, that's my expectation from their graduate degree, is they teach me something new.
That is actually true. When you start supervising students, in the first year, you kind of guide them. And then after that, you're really just learning from them. They're able to communicate things to you. And when you surprise yourself from all the new information you get, I think that's the most rewarding experience about supervising students.
Yeah.
So environmental engineering, as you've sort of outlined, that very complex, many different aspects, but it was the natural systems that you were interested in, also just because you wanted to get out in the field and get your hands dirty, as they say. But did you know at the time of the idea that we could use nature to actually clean our waters and also provide a whole range of other benefits?
Yeah. So I started kind of understanding that. Honestly, probably my first introduction to this whole world was constructed wetlands, essentially. So using wetlands for stuff like waste treatment, et cetera. And I kind of knew that was a thing when I was in the US, we would say undergraduate studies.
Mm-hmm.
And so when I went over to biological and agricultural engineering at NC State, they were doing a lot of that kind of work. And so my master's project was actually treating groundwater that had been contaminated by agriculture and basically pumping the groundwater out and cleaning it in a wetland. And that was my first introduction to this idea of natural systems, and kind of a cool project. I still love wetlands now. It's probably my favorite natural treatment system. They just do so much.
I mean, they're fascinating to me. I think my first encounter was also with wetlands when I was studying urban water management, and I saw that you can use wetlands and ponds to actually help treat wastewater. They somehow represent some very intricate but fascinating system with so many processes that you can then design and customize to your needs. I guess the only problem is that they are very big. often you need the space for them.
Yeah.
Which in a city like Melbourne makes sense, but in, I guess, denser places like Europe, it's a bit more tricky.
Yeah, for sure. And so it was actually during that time. So I was friends with a girl in my same program. She was a little bit further than I was, and she was working on stormwater systems. So this was like the first time that I really, all her master's research was green roofs. And so that was kind of my first introduction to that. At the same time, I had a crush on her. And so I used to go to her research sites and like help her do work there because, I was just trying to hang out with her. So
I guess one of the most efficient ways.
We are now married.
Oh, wow. Okay. What a romantic story.
Oh, it's fun.
No, but it's also, multi-benefit, as they say nowadays. You get to know her, and at the same time, you get to build some skills in, the practical aspects of the research and natural systems. And then it naturally occurs, I guess.
I think her paper on green roofs has more citations than any first author thing I've ever written. So yeah, that was my introduction, was like her and her work on green roofs. And then her major professors were Bill Hunt at NC State and then another guy, Greg Jennings. And I started seeing the types of things they were doing. They were starting to talk about bioretention and all these different practices. And Bill was like pretty early on in that process of people looking at those practices. And so, yeah, it was pretty fun.
And Bill Hunt has been pretty inspiring every time I've met him, also during my early years when he was visiting Australia. It was always fun to chat with him and just to see all the quirky things he's doing, not just in the research, but also in his lab. You'll have to help me get him on the show one day.
Yeah, for sure. That would be awesome. So that's why I actually, between my master's and my PhD, I worked for him for 3 years. So that was my start in stormwater. Was basically I started working for him in, I want to say 2005. And that was where I started working in the area.
And so you started in the wetlands, you got to see the green roofs. And then from what I can gather in your journey and also the publications and what you've been producing in your early years, you actually exposed yourself to many more kinds of systems as well, the bioretention being probably the most significant. But you had the chance to work on a range of different, I guess, I should ask you that question that I ask every guest, but I'll say green infrastructure. But what is your preferred term?
I usually say green infrastructure. There is a bit of a, let's say, tweaking over time that happens where I think people are like not renaming the same thing, but almost like, well, that term doesn't quite encapsulate this little thing. And so we're going to change the name. And I would say that the stormwater practices that we talk about and we work on are a part of green infrastructure. So green infrastructure would also be like riparian forests. And it would be, just the green space and urban spaces in general, whether it's meant for stormwater or not. And so I do get there is a difference. I say green infrastructure, but I'm talking about a really specific piece of green infrastructure when I say that.
Yeah.
And then the next level up now is like nature-based solutions. And so green infrastructure is kind of maybe like a subset of that also. I think all of them are kind of related, but I feel like I kind of work in maybe a more specific area that kind of falls under those two broader terms. I mean, frankly, we all try to keep up with the times and use like the most relevant or
the latest buzzword.
Yeah. So I think we all do that. I think you could call the stuff that I'm doing nature-based solutions too. And so,
I guess it's the subtle nuances between the different terms and also just their origins. I'm sure we'll compile a bit of a list of some interesting discussions from previous episodes for the listeners to then sort of go and explore this rabbit hole a bit further.
Yeah.
But I guess perhaps more relevant, for the US as well, and in my own curiosity in my early years, is there are two other terms that are quite dominant. And that one is low impact development and the other one, green stormwater infrastructure. So GSI, as they like to abbreviate it. GSI would be a subset of the green infrastructure that is more centered around stormwater. But then where does low impact development sit on there?
Yeah, you're totally right. And that's the way that I look at it too. I look at people here have started to say green stormwater infrastructure because green infrastructure is not just about stormwater. And so they're trying to define that specific realm that they're working in. Low impact development has lost steam, I think, as a term. Originally, it wasn't just about individual practices like a bioretention or a green roof. Like that wasn't the intent. The intent was for it to be more of like a holistic idea of development. And so low impact development, it might be making your streets not as wide so that you've got less impervious area. It may be looking at your lot sizes. It may be reducing the amount of compaction that you have when you put in a residential development and minimizing the number of trees that you take down. And so I think that term started to be kind of synonymous with like a bioretention is an LID, but LID was really meant to be kind of like a holistic development strategy.
I guess drawing parallels from Australia, we used the term water-sensitive urban design for a very long time. And I think many then ended up using that term to refer to solely the technologies. But in fact, it actually encompassed a much broader philosophy or practice around this idea that we need to design urban environments to be sensitive towards water, or in your case, urban environments to have lower impact on receiving waterways and other natural systems.
Yeah, and so you hear people using that term less, but at the same time, it really is still relevant for what it was intended to mean.
Yeah.
So, yeah. It gets so convoluted.
I always enjoy the terminology discussion because I feel personally that these terms help also drive people's enthusiasm to then do something in that field. And they feel like a sense of ownership for certain terms, or at least a sense of stewardship towards certain types of terms. And that, as long as we understand that there are some maybe subtle nuances between them, keeping these variety of terms and making sure everyone is aware that there are many ways to refer to the same thing, I think is, a safe way to go to keep the innovation going in practice.
Yeah. I think about there's a paper that I think Tim Fletcher was first author on, a bunch of big names on it. And it was just terminology.
Yeah.
Like, what do all these different things mean? And that thing gets cited all the time because it's, it kind of starts defining these names. But I think things have even changed since then. I think that paper was a while ago now.
Yeah, 2015, I think. And in episode 21, we actually referred to a paper that's more recent that I call the updated version of the terminology paper. Now there's, of course, the peril that everyone wants to write a terminology paper because the first one kind of made it. But I think we have to just be aware that just like reviews of different tools to help plan green infrastructure, we need to be careful not to dilute the research or the scholarship with too many of the same things.
Yeah, for sure. It's a really good point. I see a lot of lit reviews that seem to overlap, for instance.
But I guess part of also research training, because it's an ideal way to get a student started.
Oh, for sure. Yeah.
Nevertheless, this has been a very long but interesting tangent into the world of terminology. But coming back to my actual point, so you started with the wetlands and mostly in the agricultural aspect. What caught my eye in your master's in biological and agricultural engineering was that you worked with wetlands and the impact of swine lagoon seepage.
Yeah.
So this is actually a thing where there's a lot of concern around the waste from pig farms in agriculture.
Yeah. So Eastern North Carolina is a pretty big area for swine production, for hog production. And so just like in any other discipline, regulations have changed over time. And so this particular practice is, I think it's an interesting story, but essentially there was a piece of property that the university took over and they started doing research on this, basically a research farm. And they started testing nutrient concentrations in these little streams around, and they were getting crazy high nitrogen concentrations. And so it led them down this path of like, where is this coming from? And basically there was a swine lagoon there.
Oh, wow.
And it was before regulations had basically come in, and they never lined it with anything. So it was basically dug into like a sandy soil.
Oh, no.
And it just leached out. And I mean, the concentrations in the groundwater were astounding, especially if you come from a stormwater background. I mean, just night and day concentrations. And so that's kind of where there was a student before me who his whole project was like, let's install wells and try to pump this out and pump it through a wetland. But yeah, it's interesting for sure. Like,
I just have to ask this, but would the Simpsons movie be an accurate representation of the environmental impact of this? Have you seen the Simpsons movie?
I have not. Now I feel like I need to.
You have to go. I was just reminded of that when I saw the word swine lagoon, because in the Simpsons movie, Homer Simpson had a pet pig, and then things just went crazy with the waste from the pig. And go check it out. We'll have to get your feedback on that on a later date.
It's crazy. So it's like there's so much of that in Eastern North Carolina that even after regulations, hurricanes come through there.
Oh, Jeez.
and flood everything out. And all these lagoons get flooded and go into the main channel. And it's interesting. We worry about nutrients in urban settings, but if you look up some of the concentrations of nutrients from agricultural runoff, it is night and day, massive differences. Yeah.
Completely different level. Wow. But I guess nutrients stuck with you through the research. Nevertheless, you start with wetlands, then the green roof story, which is definitely very romantic. And I mean, what better place to nurture a romance than on top of a beautiful roof? Hopefully it was on top of a roof. And then from there, you moved into other kinds of systems. And you really had that exposure then to a whole range of different ways of working with nature in cities. In particular, the bioretention, which then became your sort of pet system during your PhD.
Yeah. I always say, bioretention, I always call it in my classes the Swiss Army knife of stormwater management, because it seems like every time we test it for anything, it works pretty well.
Okay.
It's like, does it remove metals? Like, yeah. Does it do nutrients? Yeah. Does it do like improve temperatures? Yeah. Does, it tends to do really well at a lot of different types of pollutants. It's easy to fit it into the urban landscape. Just kind of a simple system, but tends to work really well in terms of pollution and hydrology.
And highly customizable.
Yeah, so I think it's just going to continue to be a popular system. I think it'll be kind of tweaked over time, and every system's got their negatives, but I think it's probably going to stick around for a long time.
And you have been doing quite a bit of refinements into this particular technology. At its base level, if we think about what constitutes a bioretention system, you have plants growing on a filter bed, and then sometimes there's a drainage layer. So the selection of how you make your filter is quite important. The types of plants you use is quite important. And then how you direct water to the system is quite important. Did I forget anything else?
No, that sounds right. I think that media question is probably the one that everybody is still chasing. Like, what's the perfect media to put in a bioretention area? And, it can be challenging. One of the things that you find with that is that's one of the most expensive parts of the system is the media. There's a lot of like economics that go into that, and even questions of like carbon and energy. And if you don't have a certain material close to you, should you really ship it from some other part of the country to get to your bioretention cell? So, I think we're maybe moving into some questions like that also in the discipline. And I feel like there's always some kind of innovation that you can have in those systems.
If we start from the early days of this kind of system, they're really good at removing your general sediments. So, when it rains, all the dirt that's gathered on the streets will run off. The water will carry it all the way to these systems. And attached to them often are other pollutants like metals from the traffic or other deposition. Then there's the nutrients. We discussed it in the agricultural context, but we also have nutrients in the urban context. And these systems can, to a certain extent, also deal with them. But then you also touched upon the idea of bacteria and potential pathogens. So things that will make us sick, because if they start getting into our rivers and we go swimming, then we can actually catch something.
Yeah, I worked on that quite a bit with my PhD, just looking at bacteria and bacteria communities. And I think they work well for things like bacteria and pathogens. It's hard to get pathogen and indicator bacteria numbers down to the required number for swimming, for instance. And I would say that's even the case for bioretention. In some circumstances, like it's still a challenge to do. And so that's why people have really started looking into like more specialized media. I know Dave McCarthy and, some of the work that he's done of looking at like different types of media, different sorts of additives that you can put in media. There's been some work in California with a company called Geosyntec. California is very interested in maintaining quality beaches, and so another place where they're trying a whole lot of different things to try to remove bacteria and pathogens from the water. So that's an interesting one. There's some interesting ones with just various types of chemicals that are coming out right now.
Okay.
There's a kind of a cool study in Washington State here where, I don't know if you may have seen this, but basically there's chemicals that wear off of tires that are like fairly toxic, in particular to like a very specific species of salmon.
Okay, that specific.
Yeah. Oh, it's interesting. So they will have these salmon runs like actually in the city up there. So salmon are kind of moving back into the fresh waters for spawning. And so they'll come into the city, and then they were noticing that there'd be a storm event while these salmon are coming in, and they would be killing adult, I think it was coho salmon.
Oh, no.
Yeah, but it was like specifically coho salmon. And they eventually tracked it back to this chemical chemical in tires. So tires wearing and then a chemical washing off and actually killing fish. And so people are definitely looking into that also right now of what do we do about chemicals like that also.
It's funny that you mentioned that because I've also been recently looking into the topic of tire wear particles, because in Switzerland, they've kind of quantified or sort of made it clear that it's the largest source of microplastics from all the different sources you can get. And yeah, in Switzerland, they sort of try to manage that with bioretention systems. They don't call them that. They call them street wastewater treatment facilities. I'm just trying to translate from the acronym. And yeah, it's currently a big topic also at a federal level. But, you just describing this kind of ecological research, it made me remember, actually, when you do the ecological research, you tend to then look at one particular pollutant on one specific type of organism. It's fascinating. And I guess it just shows how complex it can be when you're really trying to link human activities on environmental impact.
Yeah, it's very interesting. Like, essentially in that study, they knew something was happening and they didn't know what the chemical was. And so they went through this pretty robust procedure to almost like basically take this cocktail of chemicals and figure out which is the one that's causing the issue. So yeah, it is really interesting. And so you look at that and then like you're saying, pathogens. I mean, the pathogens topic's really challenging because testing for individual pathogens can be really challenging. And so they are often regulated based on what we would call indicator bacteria. It's the idea that if these types of indicator bacteria are here, it indicates the presence of fecal contamination. And if you have fecal contamination, you're more likely to have pathogens there. And so a lot of the regulations in the US are based on that, have less than blank amount of indicator bacteria. It doesn't necessarily mean you have pathogens there. And so a lot of the work that I was doing with my PhD was with indicator bacteria, and when it's not quite the same as pathogens. Fortunately, we're getting more and more tools to be able to look at things like that easier and more accurately. So there's been a lot of advancements over the past 10 or 15 years in just microbiology that has brought up some interesting tools that we can apply to stormwater problems.
So yeah, you did mention indicator bacteria, and I guess it's cheaper to sample because if you try to detect a specific virus or pathogen, then it sometimes is costly. There's no guarantee that it's going to be there. So you might be spending the money for noughts. I mean, maybe not for noughts. It's good to know that you don't have it, but maybe you've missed it in your sample. And I guess you would have certain common indicators that you would select because they share similar, for lack of a better word, lifestyles to the pathogens. So they prefer water that's not salty, or they can survive in certain environments. And that's why you select them.
Yeah. So, and there's always debate on like, are these the right indicators? Should we look at different indicators? Should we just start testing for pathogens themselves? And I find our field to be really interesting because it's based on all these other fields, right? And so like as other fields have advancements, we can kind of take those tools and look at how they can help us with the research that we're doing. That's like part of the work I find really interesting, and maybe the way that new research comes out, I think, in our field a lot of times is applying new tools.
I certainly enjoy that. I mean, I like to work across disciplines. I think it's always nice to learn a bit about another discipline. You're never going to be the expert in it unless you spend a few more years going really deep. But to then be able to communicate with someone in that field, I think is very fascinating. And then when your words reach each other and you understand what you're actually talking about, that's when the magic really happens.
Yeah, for sure. I really enjoy interdisciplinary work. I work with people in other fields, and it really has kind of shaped the way that I think about things and the way that I kind of learn over time. When I first started at University of Tennessee, we had our faculty orientation, and I had these colleagues that I met at faculty orientation. One was in College of Social Work and one was in geography.
Oh, wow.
And yeah, we started working together on some things, and I found it interesting and maybe like kind of a revelation that if you really are serious about working in an interdisciplinary setting, like you do have to do some homework to figure out what it is they do and how do they communicate. And it takes a while. I remember one of them, we were having a discussion with my colleague in social work, and, I was like, well, send me some papers. So like, I want to read some papers. And it was funny. So years later, she told me like she thought I was doing that as like a test. Like, let me read your papers and see if you're worth collaborating with. And It wasn't that. I was just trying to figure out, like, what does your world look like for research? Like, how do you collect data? How do you, just trying to kind of understand the stuff that they do. So I really enjoy that. I work with people in systems and people in social work and a bunch of other disciplines. And I think it makes it fun and kind of exposes my students to new things too, which I think is good for them.
No, definitely. And this interdisciplinary work has manifested itself around bioretention systems, as well as other aspects, in particular addressing climate change in a publication that you were able to then do around this idea of backyard green infrastructure.
Yeah, and that's kind of the idea of, where do all these things intersect? And I think that green infrastructure, stormwater, it is a really great place for that interdisciplinary work because it is social and it is dealing with economics and it just touches so many other aspects of life.
Yeah. I mean, they often say out of sight, out of mind, like in our traditional infrastructures. But these things are sitting on your roadsides or in your parks or even in your backyard, as you said. And we're going to be seeing this day to day. So people need to understand, need to know how to care for them. And without the plants being healthy, it's not going to serve its function, not just in stormwater sense, but many other benefits that it can provide, such as heat mitigation, the aesthetic appeal, even carbon sequestration. So it is certainly something that requires engagement or active engagement of the many stakeholders involved.
Yeah, there's actually an interesting project. So I was in consulting. I worked in private consulting for a couple of years between my PhD and working at University of Tennessee. And we had a project where we were putting in all these backyard rain gardens in a city in North Carolina. And they looked back a few years later and there was a ton of them that were gone, basically. And a lot of it's just like a new person buys the house. They don't know what this is. And so they get rid of it or they change it or something. Maybe my most famous example is Bill Hunt. We built a little rain garden at his house. And I remember he sold that house and he moved to a new house. And basically the new owner of his house got rid of the rain garden that he had built there. And
no.
So it's like,
what a pity.
It is like this understanding thing. It's not necessarily like in the deed or in the property information, and people don't know what it is. And so that was kind of one of the outcomes of that was that there's not like an understanding when people take over ownership of a house.
I've had some exposure to this topic of private versus public systems. And in Australia, for example, a municipality I spoke to, they just choose to ignore all private systems. They didn't want to inventorize them or put them in any kind of asset management database because they weren't sure if these systems were being maintained or if they even still existed in the first place. And I guess it is costly to maintain it, even just simple gardening. You have to make sure you have all the tools, and then it's up to the owners themselves. I mean, they can hire a company, but it is quite a bit of effort.
I don't know. It's one of those topics where it's like, I don't know if it's the coolest topic out there, but this idea of stormwater maintenance has blown up in the U.S. I mean, we have I'm a part of the American Society for Civil Engineers, and we have some different conferences that we put on. And one of the ones now that gets a ton of attendance is operations and maintenance. It's like stormwater operations and maintenance. I think it's like every 2 years or something. And yeah, that's the topic. Like, how do you maintain the systems? How do you keep track of them? A lot of regulations now are putting that in as a stipulation, like the city has to or the community has to basically ensure that these things are being maintained. Like if you give somebody a permit to build and they're supposed to have a stormwater practice, then the city is supposed to go back and inspect them. And for a lot of landowners, this is a surprise to them that they don't know they even had a stormwater practice. And then they get a bill or a citation that they haven't been maintaining it. It's kind of a surprise for them.
A rude awakening, definitely. But I guess let's put this into perspective. So how many systems are there? So bioretention, green roofs, whatever you can think of. Give me a rough ballpark number. How many do you think there are in, I don't know, you can choose North Carolina, so in Raleigh, which is where you worked, or in Knoxville?
Yeah, so I'll take Nashville, Tennessee.
Okay, yep.
They've got a pretty robust maintenance and inspection program.
Mm-hmm.
And so they have, I'm probably mistaken on the exact numbers. I think they have maybe in the range of 4 to 5 permanent staff who this is what they do. They inventory and inspect practices. And I don't know the exact number, but I mean, It's got to be in the upper hundreds to thousands. Yeah. I
Wow.
mean, there's tons of them. And it's a really rapidly growing area. It's not stopping anytime soon. It's one of the most popular or one of the most frequently implemented practices for them now is bioretention.
That's good to hear as well.
Yeah. No, they've got a great stormwater program. But yeah, I mean, that's a huge burden. Like, you know, a city like that's got more money than a small municipality. And so they can do some things to manage that. But man, I mean, I'm always surprised when you actually think about having that many staff and that's what they do.
Full time.
Yeah, it's wild.
No, definitely.
I'll have to find the number for you at some point. They sent us statistics one time on how many bioretention they had. I can't remember. I'm sure it's outdated now, but hundreds to thousands. I mean, it's a lot of practices.
Just to think of the number, I mean, it's comparable to Melbourne. They had the 10,000 rain garden program across 8,000-ish square kilometers, at least the greater Melbourne metropolitan area. And that number has probably changed significantly since then. You know, it's in the regulations, so people have to do it. But yeah, trying to then document all these assets, maintain them. I know in South Australia, for example, talking to some practitioners there are companies that specialize in the maintenance of these systems. So in a way, it helps because you have someone that in a way knows how they work and goes around and actually inspects them and makes sure that they're up to standards. But yeah, as you said, small municipalities, resource constraints. So A, you got to get it right in the first place. B, you need to be strategic about where you put them. And then C, hopefully have enough money or to build them in such a way that you can afford the maintenance.
Yeah, so this is blown up as like an industry in North Carolina. North Carolina, you know, is kind of, they've had regulations like this for a long time. And these maintenance companies are like, there's been a number of them that have cropped up and do really well. I was actually told recently that those companies are being like bought up by bigger companies. They are, I guess, lucrative enough that other places are buying them up. And it's interesting. And so, you know, maybe another positive is we're starting to create new industries. Tennessee is not as far along as North Carolina in terms of our regulations have not been in place as long. I told my wife one time, I'm like, you know, we should just start a company selling bioretention media because it's going to go crazy at some point.
Yeah, there's a market for that. And if not in the US, then certainly over in Canada. We've had some guests on the show that actively work on the topic, but also, across the world as well. It's being taken up. As you said, it's a Swiss Army knife. So yeah, you can definitely customize it and ensure that people use the right media to actually achieve the benefits they want.
That was a hard pass from her. She was not interested in that.
Oh, okay.
It's maybe not the coolest industry to run, but
I mean, you can think of ways to market it, right? You know,
yeah, exactly.
Especially do-it-yourself backyard kits. Now, but regulations. I think when this technology started, regulations weren't necessarily in place. You know, I go back as far as the 1990s where I was reading papers about the system. I think in the US, it was basically Bill Hunt, and correct me if I'm wrong, but I think the other big name in bioretention research was Alan Davies.
Yeah. Alan Davis has done a lot of work. And so I'm sure people would argue on like origin stories and who did what and when. But there was kind of, that confluence of stuff. Like I know there's some papers out of like Australia and the US are around the same time frame, kind of starting to document these. And I know kind of in that mid-Atlantic US has been one spot where a lot of this developed, at least in the US. Now, I will say for context's sake, this has become really interesting to me, this idea of where did this originate? Because it has implications for other places. If you look at the U.S. in particular, the places where these have been used extensively and originated, it's really a lot of coastal type states. So it's like Maryland, it's Virginia, it's North Carolina. And this has been interesting for me coming to Tennessee because we have challenges that don't necessarily fit in the box that you would have in coastal areas. So for instance, we have shallow bedrock sometimes.
Mm-hmm.
Like I've heard stories of people telling me in Nashville that they've had contractors literally chipping out bedrock to try to get the correct depth of media for their bioretention.
Oh, wow.
Because the bedrock is so shallow. You've got issues with sand availability. We don't have the same availability of sand as they do in places like that are in those coastal areas. And so I think there are some unique challenges in places that don't fit into that mold that have not really necessarily been picked out quite yet or have not been necessarily addressed quite yet. And I think it does go back into the idea of climate change and carbon and, do you want to ship sand in from somewhere else or is there some other type of material material that we can use more locally.
This just goes to show that there really is no one-size-fits-all solution, because you need to understand your location and to see how you can tailor the systems in your own location to suit the needs and also the priorities as well.
And so what happens is when you start something in one location and you put out design specifications, for instance, those get replicated all over the place. And so I'll talk to people sometimes in Tennessee and it's like, well, the bioretention media is this. And it's like, do you know where that came from? It's like this coastal Maryland, that they're selecting media and coming up with these practices. And so, yeah, I think there is probably a need for more catering of things to specific places, because we have, maybe out of necessity, like you look at what are the first design specifications and you use them. And then they're not always necessarily perfect for your location.
But it's a start.
Yeah.
But on the topic of regulations again, and this also relates a bit maybe to terminology. So I'm trying to think of which one to go in first. And maybe terminology, because that helps clarify regulations a bit. And I've had this discussion with Belinda Hatt on episode 20 of the podcast. And we actually distinguished between 3 terms. You've mentioned 2 of them already. One sort of came out subtly. But people tend to call these kinds of systems bioretention, rain gardens, or biofiltration. So yet another interesting mishmash of terminology with subtle nuances. But how would you differentiate them? I mean, you use bioretention predominantly in the US, but in Australia, I know biofiltration is quite popular.
So I typically will call stuff bioretention as like a general term. The term rain garden for us is it would usually infer to something that's more like a backyard home scale, like an individual's home scale installation. So we'd call that a rain garden, and it's basically just a bioretention that's catered to like that specific context. We also will use rain garden as maybe like a community-friendly term. It's easier to understand rain garden installation in the center of a city where it's going to be super public and people are going to be around it a lot. That's a more like friendly and approachable term than bioretention. And so to me, it's like rain garden would be a bioretention with maybe it's just a term that's a bit more friendly to the public.
Yeah.
Biofiltration. So there's all these like things that people debate on, like, where's the water going to go, right?
Yeah.
Is it actually infiltrating into the ground, or is it just passing through the media and then getting pushed back into the sewer? And so a biofilter to me would mean you're not necessarily getting a bunch of infiltration out of the system. You're basically just like filtering it and then routing it back to the sewer. I don't know. That'd be my interpretation, but who knows?
Well, but then there's the retention, I guess, that clearly illustrates the process, and you're slowing down the flow. You're reducing the peaks, because when we urbanize, and it rains, oftentimes it's a lot flashier and floodier, if that's a word, when the water comes off compared to a natural circumstance. But then that's where the retention comes in. So you slow it down, but then there's also the infiltration. So it's almost like, more confusion in terms. But anyways, the reason I thought I'd bring up the terminology debate first is because my understanding, and correct me if I'm wrong, in the US is that a lot of the regulations are based strongly around runoff volume reduction. And if you can reduce the runoff, or you can remove it from entering the waterways via surface, then oftentimes you also reduce the pollutants that come with it, because in a way you're handling the pollutants in the system and essentially physically removing that water through the system. I mean, it goes into groundwater in most cases, or in some cases. But am I getting the gist here?
Man, you just opened up a can of worms.
Oh no.
You could talk for a week on regulations and how they vary based on location in the US. There's challenges in the US with how we can manage and what we actually are allowed to regulate. So the Clean Water Act is kind of the major legislation of kind of like environmental regulation related to water in the US. So we had chemical issues, or chemicals getting discharged into rivers. And this was the first set of regulations that was like, as a country, we should have waterways that are fishable. You can fish in them, you can drink the water, you can swim in them. And so that's kind of Clean Water Act is like, let's have waters that are swimmable, fishable, drinkable. And so in the Clean Water Act, technically, it gives the EPA the right to regulate pollutants but not volume.
Oh,
So
wow, okay.
water volume is technically not regulatable for the EPA.
Yeah.
So the EPA is not allowed to be like, everything has to come back to pollutants if it involves the EPA and EPA regulation.
And just to bring context, I am aware of the fact that there are some pollutant regulations around loads, concentrations as well. And the reason I only bring this up is because in Australia, the systems tend to be a lot smaller because it's been targeting the pollutants mainly. And now recently, with changes in some of the planning ordinances, particularly in Melbourne, they've started targeting volume as part of implementation of green infrastructure. But yeah, okay. So we're on the EPA and pollutant regulation, but not volume.
Yeah. So different states and entities will deal with that issue differently. So there's this idea of what is the maximum extent practicable and stuff like that, where they can interpret it in different ways. Tennessee has recently put out a set of regulations, and it tries to incentivize implementation of things that are going to give you volume reduction, essentially. And so if you're going to implement something like bioretention, where you're going to get infiltration and volume reduction, you have to treat a certain size storm. If you want to use something like a wet pond or a dry pond, you have to treat a bigger storm. And so there's like this tiered approach where it's basically like you can use other types of practices, but it does try to incentivize using practices that also provide things like retention and infiltration. So it's very hard because there is, like you're saying, this load linkage between pollutants and volume reduction. But it's really like a tricky, like legalistic argument about, what are they allowed to regulate? What are they not allowed to regulate? And often for us, I think
to use an analogy, just to illustrate what you just said, I guess if you're cooking a nice roasted leg of pork, you do it for two people. But if you want to bake a whole turkey, you'd rather do it for an entire family, right? It's that kind of thinking.
Yeah, it's interesting. And the US tends to be a very legalistic country. And so at the end of the day, stuff gets figured out with lawsuits. So the way that Tennessee came about, what they did is they put out a certain set of regulations, they get sued, they kind of go to a negotiating table and they figure out what's actually going to happen or what are the regulations actually going to look like. But this was a thing that came up in, I believe it was Virginia, where the EPA got sued and they were like, you don't have the authority to regulate volume. And technically that is correct. The EPA is allowed to regulate for pollutants. So yeah, so you will see volume reduction in some places. And it's very convoluted. There's no real standard in the country. Every state seems to have their own regulation. Okay. And then municipalities will sometimes do things that are different than that.
Yeah, in a way, it's an iterative approach that gets refined gradually. I guess the process of refinement is a bit involved and arduous as well, based on what you just described, especially with the Virginia case.
Yeah, and it depends on where you are, right? And so Nashville had a gigantic flood. I think it was in 2010, maybe, where downtown Nashville got flooded by Cumberland River. And I was talking to one of those guys, a person over there in Nashville, about regulations and stormwater, and they're like, yeah, we don't have the same challenges of convincing people because they remember this flood. And so anything we do for water is well received because of that context.
In a way, you highlighted that as well in that study that you did on the backyard green infrastructure, where the awareness was predominant in the people who experienced the floods or those who had some extensive education on environmental issues. I guess that's where the opportunity lies to then help the adoption and help the uptake, but then also help guide the regulations so that we meet the expectations and we have the people bringing stewardship to the whole practice.
Oh, man. Yeah. The regulations thing is it's so complicated. And I think it's easy for academics to sit there and poke holes on you should have done it this or this or this or this or this. But, I've worked with enough regulators that it's a really hard job.
Yeah.
You run into engineers who are like, hey, I've been doing this forever. Why won't they let me tweak things because I know what I'm doing? And it's yeah, but the regulation wasn't really written for you. It was written for somebody who doesn't really know that much and they need a cookbook to follow. And so, yeah, you're trying to write some regulation that can be used by everybody, that can be understandable enough that any engineer is going to understand it. And man, it's really complicated.
I guess adding to that, shall we open yet another can of worms, which is the story of climate change? Because you've not only dealt with the system and the design of it, but you've also looked at what we're going to be facing with climate change and how well these systems are still going to do. I think this is something we need to really realize. Any kind of infrastructure planning and design we do nowadays, we need to account for the fact that we may be using our historical knowledge, data, and experience to design them. But that's not going to be the case necessarily 50 years down the road, or 30 years even, or even just 10 if we're seeing the changes now. So what can we expect with these systems? Are they going to still be doing their job in 10, 20 years when we are facing new kinds of rainfall types and intensities due to climate change?
Oh, yeah. So another challenging one, right? Yeah. So climate change it's an interesting topic. And I think that we tend to look at it a little bit ubiquitously. We're going to have these effects everywhere. And I did a study one time where we took some of the same approaches that we were using. And my friend Ryan Winston, who works at Ohio State University, we used some Ohio data and we looked at the same type of thing. And it was like no real big change because the place where we were looking at, the rainfall patterns weren't really going to change that much.
Okay.
And so there is a big change depending on where you are, on what your expectations are. I would say, in general, everyone is expecting more rainfall with a fewer number of events. So more intense rainfall events. And that creates a challenge for things like green infrastructure because they are not really like a flood abatement strategy. You know, it's more of like small frequent storms. We're going to be able to take those on really easy. And people have tried to look at what do they do for us during flooding. But during a really big, intense event, you start overwhelming the watershed, whether you have storage or not.
Yeah.
And I think we're rapidly moving to a point where we really have to start focusing things on floodplain a lot. Green infrastructure is fantastic for what it does, but it's not necessarily going to alleviate some of the types of events that we're seeing. So one of the worst things we see are like these cloudburst events. So big amount of rain in a short duration. Nobody designs drainage infrastructure for that.
No.
And I don't even know if it would be cost effective to design infrastructure for that. And so you start moving towards like those events are just going to happen. Like, how do we deal with them? I really think that we're going to start, or that we should start seeing more, multi-use landscapes next to rivers and streams where it's okay for things to flood during really intense events. We see examples where like there's football fields or playgrounds or something, maybe not playgrounds with kids, but, green space that can be flooded along the floodplain, I think is a really important thing. I think floodplain regulations are a really important thing to consider because I'm not convinced that some of the storms that we're seeing are going to be fixed by upland landscapes.
Or putting in a bigger pipe.
Yeah, we've got Smoky Mountain National Park is 45-minute drive from where I am. And I'm like, if it rained 10 inches in this pristine green space, it's still going to flood. There's a limit to like storage capacity.
Because it all gathers up at some point.
So I'm like, if you're going to get flooding in a pristine green space, nothing you can do in a city is going to really replicate or do any better than that. So I think some of the intensity increases are going to have to be handled in channel. In my opinion, I mean, that's just kind of my thought on it. I think some of the events are just going to be too big and too intense to deal with in upland storage.
But I guess we're starting to see examples in urban design in particular of, you mentioned the playground, but that actually exists where they have playgrounds that then, during a rain event floods. And I guess you hope that your kids don't go out and play during the rain event. But the intention of creating flexible spaces, multifunctional spaces, so that we can actually live with these kinds of extreme events and also accept them as a day-to-day occurrence, I think is happening around the world.
Sometimes the university will put us up for like, if you need to talk to somebody about some recent event, here's some ideas. And there was a hurricane that hit Houston, I don't know, maybe 5 years ago or something with like just huge amounts of flooding. And they were talking to me about it. It's like, what can we do about such? And they like knew my area of research. And it's like, what can we do about these issues? And I mean, I'm going to use non-metric terms because we are like one of the only countries that has not adopted this yet. But it rained like 20 inches, and it's like, if it rains 20 inches, there's not much you can do. Like, get out of the floodplain.
Don't try to fight it in the first place. I mean, you're going to have to deal with it.
Yeah. So I think that stuff's interesting. I think aside from rainfall, I think the climate issue is really interesting, this idea of heat in urban spaces. And I've seen a lot of people starting to look into that also of like, what can we contribute with green spaces for things like urban heat island and just increased temperatures? I think that's kind of an interesting area. I think the idea of dry conditions is also interesting. Whenever we think of green infrastructure, we think about flooding and what are we going to do during rainfall events, but what are we going to do with things like plants and trees and microorganism communities if we have big dry periods in between rain events?
Yeah, that's very true.
I think that's another thing to kind of think about. We know that dry conditions cause some pretty big impacts to things like microbial communities. And so, yeah, I think there's a lot of interesting questions that come out. So I would say, yeah, I think green infrastructure can contribute to rainfall management. I think we're still going to get periodically these events that we are not able to handle on the landscape, and we're going to have to shift to thinking about these blue-gray infrastructure or multifunctional spaces. And then we're also going to have to think about all these other issues that are coming up with just heat and urbanization. And yeah. So one other thing that's interesting about urban heat island, obviously we talk about evaporative cooling and we're trying to get evaporative cooling. But the way that we structure these green infrastructure is actually pretty interesting. Like as long as I've been in stormwater, the whole story has been infiltration, get the water out of the system and into the ground. And so we're taking like 10 times more water than this footprint would normally see. And we're trying to get infiltration in it. We don't know as much about evaporation and how much evaporation that we're able to get out of the system. So something like a bioretention area, yeah, you're going to get some evaporation. Things like permeable pavement, not so much. And so
yeah, true.
I think we maybe have to think a little bit about maximizing evaporation in some of these systems also, and what are the ways that we can do that.
And I think that's something that we are also starting to go into deeper with these kinds of systems, understanding how we can tweak the water cycle. So the water coming in, the water going out, either through infiltration, evaporation, or evapotranspiration, and then what aspects we can then do to optimize it. So there's still certainly a lot of open questions, and not necessarily on stormwater management, but to maximize using stormwater management or the water cycle, all the other benefits that these systems can provide. And so we talked about the maintenance, we talked about the design of these systems, we talked about the long-term aspects and climate change impacts. And one element that you're embarking on now quite intensively, that's, it brings all of these together, including also the social aspect, is something around the monitoring, but also the control of these systems. So in traditional infrastructures, if we think wastewater systems, sewer systems, and wastewater treatment plants can be controlled quite nicely. You can tweak with levers and knobs how the water then moves through the plant. And now you're looking at how we can do it on these kinds of nature-based solutions or green infrastructures as well, which I find quite interesting. Tell me a bit about what would we actually be looking at, first of all, to then control in these kinds of natural systems?
So things have come a long way. I talked earlier about how as we get developments in other research areas, different spaces, it kind of comes over and we can use those ideas. And so there's been a lot of improvements and research and developments in like data transfer, in sensors, in, what we're able to do cost effectively and fairly easily now. And so we've had this idea of real-time control or active control, or essentially using sensors and valves to change or inform the way that we want systems to work. When I first heard about this, I was not into it at all because I like natural systems. And so it was like, can't the natural system just figure it out? But the more I learned and started kind of dabbling in this area, the more I saw there are a lot of interesting things and a lot of value here. If you are a natural system person, one thing you kind of have to wrap your head around is urban areas are not pristine natural environments to begin with.
No, very true.
And so there's some amount of engineering going on anyway, or human manipulation that's already happened. Part of what I started doing is collaborating with people in this like systems world. So Anahita Kojandi is a person I work with a lot at University of Tennessee. I work with Branko Kirkez at University of Michigan. And they had a different perspective on watersheds than I did, looking at it more like a system. I'm sure a lot of people, this is like obvious, but the idea that just dropping a practice in the middle of a watershed doesn't really allow you to think about how that thing connects to everything else around it.
I guess a relates to your example just now about the uplands control and the national park. And with the 20 inches of rain, the city's going to flood anyway because everything's connected.
Yeah, it's just this connectivity. And so you start realizing and there's been people who have looked at this. If I throw a bunch of ponds in a watershed and I don't think about how they interact with each other, you can make things actually worse or not really get any improvement. And so I've always been interested in monitoring and sensors and stuff like that. And I started realizing, oh, wow, you could actually start controlling stuff like ponds more as a system. And it really brought on this research project that we're working on now, which is, in theory, if I had a control of enough ponds in a watershed, I could start making the stream flow in different ways. I could look at, how do I reduce flooding? How do I improve some condition that I'm interested in, etc. And so it made me think, if I could control a stream however I wanted to, then what should be the flow regime in an urban stream? I know there's a lot of people interested in this, but we historically have not done a great job of taking people who work in stormwater and people who work in streams and having collaborations or understanding those two systems are connected, right? So I think stormwater all too often is, I'm going to put a bunch of stuff up here and I infer or I believe that there will be some good outcome in the stream. We don't really know that. We didn't plan for an in-stream outcome, right?
Yeah.
And stormwater really matters because of the stream. That's what the end goal is. And so this was one of the first times that I saw a direct connection between, I can put something in the upland, I can control it, and I can actually see the impact in the stream. With the sensors and controls, it's much easier to pick out specifically what we're doing. So yeah, it was kind of an opportunity to look at that. And so our new project essentially has a colleague from industrial and systems engineering. And so they're looking at, how do you actually model this as a system? We have the whole watershed and swim, but swim, as it turns out, takes a long time to run.
The all too famous EPA stormwater management model, which I know has been the go-to for a lot of green infrastructure projects and research around modeling as well.
Yeah, no, it's fun to watch this other group of researchers from systems engineering trying to work with it. And they're like, this is so slow. When you start talking about, I want to run 10,000 simulations, it gets out of hand really quickly. So
yeah, that's a big number.
Yeah, so they're kind of working on that optimization side of things. And then we have a colleague from fisheries and wildlife. And so he's looking at what's in the stream now, what type of fish are there, how does the system functioning now? And our goal is to try to pull all those things together to say, we can give these systems engineers our objective functions. What are we trying to achieve in the system? And they can try to optimize their models to achieve those things.
And at the same time, you're looking at really the technological level as well. Some of the initial work you've already produced from this endeavor has been about controlling individual elements of a bioretention system as well. And you've been doing that experimentally in the lab, trying to see what happens if we change certain aspects, if we control the flow through the system, and what that also means for pollutants and removal of pollutants.
Yeah, I mean, there's so many different levels of things you can do. It's like that fundamental environmental engineering. What conditions do I need to create for blank to happen? And then it's easier to create those conditions when you use sensors and controls. It's easier said than done, right? So we've got a bunch of dry ponds and they get clogged. There's vegetation everywhere. And so actually making it work, I feel like, is easier said than done. But I think the science behind it and trying to look at the capabilities has become really interesting. And we talked about the maintenance issue earlier. I mean, how can we use sensors to inform maintenance? It's another big thing that we think about.
Very true, very true. So I guess the future goal in the next few years from Jon Hathaway will be the smart stormwater system, the smart GI across the catchment, or the watershed, as you call it in the US.
Yeah. And to me, it's I think the real-time control is interesting, but to me, that's almost just like a means to an end, right? It's not necessarily about the technology for me personally. There are people who really enjoy just looking at the technology itself. I'm really interested in watershed scale management and how do you restore a stream or how do you get upland assets to work at the stream level? And this is just the most direct way that I've ever found to do that. where it's like, I don't know exactly what happens when I install 1,000 bioretention areas. I think it's good, but I don't really know. But if I took 10 huge ponds and I put controls on them, you can see the impact in the stream. And so I think that's the scientifically interesting thing for me, I think, in this project.
And it'll be very exciting to see where you take this in the years to come. So I definitely look forward to it. I'm certainly dabbling at the interface of it slowly as well, because I think that understanding that digital twins, as they call it now, as one of the buzzwords, is a very strong area of modeling that I think we need to start looking at as well, given the capabilities of technology. And we should be able to do something very smart or very insightful with it so that we can deal with the non-stationarity of climate change and the impacts of climate change. And at the same time, be logistically more, I guess, helpful in terms of managing these thousands of systems that we just plonk all over the city, and hopefully strategically as well.
Yeah, hopefully strategically.
No, definitely. Jon, this has been a very fascinating talk, and I've been learning lots and drawing a lot of comparisons with my own experience around this area. But like I do with every guest, I'd love to ask you a few questions so that listeners can learn even more about you and I guess how you think and what drives you as well. Starting with the very typical one, now when you wake up every day with all the different areas you've been in, what is that key inspiration that drives you to do what you do in the natural systems and beyond that?
Yeah, I think it's two things. So the first thing is, I like being out in nature. I like hiking. I like riding my bike. And there is some element of trying to improve environmental conditions that's always going to underpin the stuff that me and a lot of you and a lot of colleagues, it's always going to be an important part of the work that we do and how we think about our work. I find it very interesting, like these systems and cycles that are in these practices and in the natural world, and understanding how things like wetlands process one thing and then it turns into something that can be used by this thing. And like this interconnected nature is really interesting. And so I get really excited by data and results and my students showing me stuff and trying to like look at this information we've collected and try to decipher what it means.
Ooh, I love data as well.
I think there's still like this mystery of research, and that still fascinates me and is still interesting to me, trying to figure out what's going on in a given system. The other thing is that I'm super passionate about my grad students. I really like working with my students, seeing them succeed, working with them one-on-one. I tell them, I'm like, working with you guys is like one of the best parts of my job. I enjoy those interactions. And as I get older, I like to say they keep me young.
No, that's a nice way of putting it. I love mentorship. I like mentoring students and seeing them. The moment they understand something, that epiphany moment is so rewarding. And then they feel so appreciative and then get even more inquisitive and want to learn even more. And it's just lovely to see the ambition.
Yeah, I mean, and that all of us work with really bright people. These are like really bright students that we work with. And it's like inspirational for us to see people work hard and come up with new information.
And fresh ideas also for the newer generations. When you think about how the younger generation now learns, during my time, laptops in school weren't a thing until late in my education. But nowadays, it's almost ubiquitous. So technology brings us along. And if we can learn from them, I think it gives us a thing or two we can then play with in our own work.
Yeah, people think I'm joking, but I'm like, with pretty much every student, they reach a point where they're doing stuff that I can't do. Like, I don't know. I don't know how they're doing it, but they're figuring out stuff that I would not know what to do. So it's fun to learn from them and see the skill sets that they have.
No, definitely. Is there a key moment, event, person, or book that completely changed the course of your career or mindset?
Yeah, I mean, I would have to say Bill Hunt was that for me. I mentioned when I finished my master's, I went to work for him for 3 years. And that position's kind of like understandably not an end goal. You're going to move on from that position. And I was trying to figure out what I wanted to do next. And it was actually a bunch of data on indicator bacteria from a study we were doing in Charlotte, North Carolina. And I was super excited about these like trends and like data that I was looking at. And he had talked to me about doing a PhD before, and I didn't really ever like think about it much. But for some reason, he talked to me that day and he was like, all the stuff you like to do is what you would do as a professor, and kind of laid it out for me. Like, this is what your PhD could look like, and this is what we can do. And it hit me that day like it had not before. And I was like, yeah, I mean, I can kind of see that now. And decided to go back to school. I'm really happy that I did.
I also have that person for myself as well. Anna Deletic, who's been on the show, also a memorable episode for me when I recorded her. And it was, very similar kind of story. And they really take you along and they inspire you to really pursue this kind of career trajectory.
Yeah.
What was one of the most challenging situations that you've ever faced in your career to date, and how did you overcome it?
What came up to me when I read this question was funding in the U.S. And the way that the U.S. is structured is very much a competitive funding process. And I have to say I'm naive on how this happens in other countries, but we don't have like guaranteed funding. Writing grants, going after money. I have to write a lot of national level grants to funding agencies. And so keeping consistent funding can be challenging, and it can be hard to have like a steady state. I've had times where it was like a bunch of stuff going on, and I've had times where I'm like, oh no, where's the next grant coming from? And so I think that's a tough part of the job, I would say, for me, is steady state funding and trying to figure out how to keep things rolling, essentially. I know a lot of us deal with that, but it is challenging.
Do you find that it also hits you at a more personal level when you don't get the funding because your project proposal has been rejected? Do you start to think to yourself, am I doing the right thing on the right path? Is the idea good enough? Am I good enough even? Do you feel that happens? Yeah.
Yes, absolutely. We talk about imposter syndrome, and I'm like, I absolutely have that. I always joke that every time I get a grant, it's just like, what's the next one gonna, like, I definitely have had multiple times where I think that I'm never going to get another research grant. And so, it plays with your mind a little bit, but I totally feel that way a lot of times where I don't know where the next funding is coming from, or I'm nervous about this or that. And it's a profession that has a lot of rejection, between papers and projects. And there are some real highs, but there's some lows when you have a lot of rejection in this career.
And any tips you can offer to, I guess, cope with it, or to deal with it, or to keep moving?
For me, I usually allow myself like a day to be upset about it.
That's a good way.
Yeah. If I don't get a grant, I'm not going to pretend like it doesn't matter. I'm going to probably feel pretty sad and upset about it. And I give myself time to do that. And then, I just try to kind of pick back up and keep moving after that. And I think you kind of have to look back at your past and your record and be like, okay, I have had success in the past. And so forecasting in the future, you would think that I will again have success at some point. But I usually give myself some time.
Yeah, forecasting is the dangerous aspect because sometimes research feels like random noise and not an upward trend or a downward trend. But it's nice to know, because if you're on a downward trend, it's not necessarily going to keep going down.
Yeah. I've definitely had times where I had big lows in funding and stuff like that. And I try to just be honest with it, with people. Like, that's just kind of part of the business. And I think it's okay. And a lot of people deal with that.
And you build resilience over time by experiencing it. And I think it's better to experience it early, as long as you're stable, but experience it early so that as you grow and you progress in a career and then you start managing a team, you can deal with these emotions a lot more readily, and then you know what actions to take.
Yeah.
So if you had a magic wand and given everything we've discussed, any challenges we've discussed, and you could change one thing about the current situation, be it research, be it the world, what would you change and why?
Oh, this was so tough. I struggle with this one the most. So I'll think about the context of our discussion here. I think the way the regulations work in the U.S. is very much parcel scale.
You want to open the can of worms again?
I know. Like
I thought we closed it.
An individual property has to take care of the stormwater on their property. And there isn't much consideration of like system scale impacts. And I think that makes things challenging. It's tough because every watershed's unique, and we don't have the resources to go through every watershed and figure out exactly what it needs. But the regulations at the parcel scale, it's challenging.
So being able to wave the wand and somehow make it work.
Yeah, I think being able to put more thought into where we put practices and more thought into the implications of those practices, I think would really result in more cost-effective and performance-wise benefits in watersheds. I think the other thing for us, probably in the US, magic wand, which I'm sure happens everywhere else, is like development in floodplains. There's places where it's already happened and you can't really backtrack from it. But as we deal with climate change, those areas that are in the floodplain and the places that we built inside of floodplains are going to have problems.
Oh, yeah, that's true. And changing that overnight would be, wonderful.
Yeah. I mean, like we talked about, you run into all these social issues. You can't just go into an area and tell people they have to move,
No.
And so, but in reality, I mean, keeping people out of those areas that are going to be flood prone is, I think, one of the biggest things that we could do to deal with climate change. But man, yeah, that's a really challenging one.
Very true.
So maybe magic wand, all of a sudden we have bigger setbacks from the stream.
Hey, perfect. Why not? And we can make the world a bit bigger in the process, because I guess when you set it back, you sort of expand everything. No, but I think, bringing in that more strategic thinking, I wish I could do it overnight sometimes, because when I see where the systems are being implemented and that they're still being seen as a shiny new object, if you want to call it that, everybody wants to have it, but then we forget to think about, well, maybe we should do it properly and strategically rather than just the nearest opportunity.
Yeah.
Yeah. What tips and strategies can you offer in terms of time management? How do you maintain a balance between your professional and personal time?
I have people ask me about this, and I think this is maybe like too much of an academic answer, but I feel like sometimes we focus on the wrong time scale when we talk about work-life balance. And I feel like some of my students look at it as like a daily balance. On a daily basis, I need to have balance between work and personal. To me, it's a bigger time scale balance, like over the course of a month, over the course of the year, I should have balance in those things. I just don't think, in particular in academia, I don't think you're ever going to get away from, like, there are periods of time where you have to work a bunch to get stuff done, to like get a deliverable out, to write a proposal. And that's okay. It's okay. And it's also okay to leave on a Friday and like take some personal time. So thinking about it at a different time scale to me is important. That balance is really important, but it doesn't necessarily happen on a daily or even weekly basis sometimes, depending on what you have going on.
That's such an interesting way of seeing it, because, I feel the same in a way. Sometimes I'm working a lot day after day, nonstop. And then I'll say, it's Friday. I'm sort of exhausted. I need to rest. And I feel the balance is very important because it helps you reset your mind so that you can be efficient again. But to see it at a much broader time scale than just a single day, it's a nice way of putting it. Definitely.
Yeah.
So for young environmental engineers starting out and the many students you have, what advice can you offer to them?
So one of the things that struck me actually when I was in consulting was that we all, like, when we're in school, we get this perception that everybody has this really like linear path to get where they are. You do this step and then this step and then this step, and like it works. And maybe it's comforting sometimes. Maybe sometimes it's not comforting to say like it's not a linear process. Like sometimes if it was a linear process, it might be easier. But what I would see it in consulting is I would look at different people's resumes and whoa, like people had all sorts of different ways that they got to where they were. And so I try to tell them every decision you make or a place that you work, it doesn't have to be the last decision or last place that you work in your life. You can work for a while and go back to school. You can change companies. I feel like people don't need to feel stuck where they are because when you look at people's resumes, CVs, like everyone kind of gets to where they are in a different way. So that's usually my advice to students. There's not really a perfect pathway. Maybe that's good news or bad news, but
but be aware of it in a way.
Yeah. I mean, I had a really different pathway than other colleagues, and it's just hard to put your finger on how you got exactly to be where you are.
And I think sometimes the journey, when you look back at it, there's no way you could have ever predicted where you are now. Certainly in my own journey, it's much more interesting, the route I took compared to if it was a stock standard process. And that's the joy.
Yeah, I tell my PhD students, it's like, especially with PhD and faculty positions, you have to be really honest with people and like, listen, let me tell you about my journey. Like I applied to, I don't know how many places. I had a bunch of interviews and I got one job offer,
And that's all that counts.
And like, I'm happy that I ended up where I am, but for sure, like it can take a long time to get to that point. It doesn't mean you won't get there, but it may not happen exactly the way you think it will.
No, indeed. So enjoy the journey. Where can people find you if they want to get in touch?
Yeah, so you can find me. I'm on LinkedIn. Our university kind of puts out websites, and so you can see me on there. You can catch me on LinkedIn. And I also have a website, just hathaway.utk.edu.
And we'll put this and other information, as well as all the topics we've discussed today, in the show notes so that listeners can read a lot more and more in depth about the world of natural systems, climate change, green infrastructure, and terminology even. But Jon, it's been lovely chatting to you and really just exchanging our own experiences and seeing how they compare on different sides of the globe. And like I do with every guest, I always give my guest the final message. So one last message to the listeners to take away from today.
All right. So I thought about this. I have a paper that I have stuck on my bulletin board outside my door. And it's this paper by Martin Schwartz. And it's called The Importance of Stupidity in Scientific Research. And I love it. And it's a very interesting paper where he talks about like feeling stupid during his PhD because he didn't really necessarily know how to solve every problem. And it got to a point where he was asking a faculty member for their advice on something. And he said this faculty member a few years later won the Nobel Prize like in this area. And they replied to him like, I don't know. And he was like, it struck me that nobody knew. You know, that was what he was there for, you know, to kind of figure out this problem or figure out a way to go about solving some issue. And so we have to be okay with not having the answers all the time. I feel like when you think you have all the answers, you've like lost an opportunity to learn. And so I really try to learn from other people and ask questions and try to feel okay, like sounding dumb by asking questions and, you know, not knowing everything about a subject. So look that paper up. It's really interesting. And yeah, I think it allows us to see academia as a chance to like be comfortable not knowing things.
Thank you very much. And that wraps up our amusing yet insightful episode with Jon Hathaway. For more insights into green infrastructure customization, the latest on its progress and control, or just a guide on mountain biking or romantic green roofs, check out the show notes for more information over at petermbach.com/podcast. And as always, thank you listeners for tuning into this episode and for your feedback and support. If you're enjoying this show, I would be incredibly grateful if you could share this podcast with your family, friends, colleagues, or even fellow engineers. Please also do subscribe or follow this podcast on Spotify, Apple Music, or wherever you are listening from to be notified of the latest release as soon as it becomes available. If you're curious about me or my work in general, you can also check out my website or social media. Head to petermbach.com, my YouTube channel, Peter Marcus Bach, that's Marcus with a C, or follow me on X, formerly Twitter, @petermbach, or Instagram @petermbach87. Feel free to reach out to me with any feedback or guest suggestions so that I can keep improving this show. The podcast's intro and outro song is called Starsky by Alex Kieran. Stay tuned for our next episode and next guests to hear how they are tackling the grand challenges.